Kinematics versus dynamics, exploring the fundamentals of motion. Kinematics and dynamics are branches of physics that study the motion of objects, but they focus on different aspects and principles governing movement, forces, and interactions in the physical world. Understanding their distinctions helps in comprehending how objects move and interact under various conditions. 1. Kinematics overview. Kinematics is the study of motion of objects without considering the forces that cause them to move. It focuses on describing the position, velocity, acceleration, and trajectory of objects purely based on their motion characteristics. Kinematics deals with concepts such as displacement, speed, and time, providing a mathematical framework to analyze and predict the path of moving objects. 2. Components. In kinematics, the primary components studied include position, location of an object in space, velocity, rate of change of position over time, and acceleration, rate of change of velocity over time. These quantities are described using mathematical equations and graphical representations to depict the motion of objects without regard to the forces influencing their movement. 3. Applications. Kinematics finds applications in various fields such as engineering, robotics, astronomy, and sports biomechanics, where understanding the motion of objects or systems is crucial for design, analysis, and performance optimization. It helps in predicting trajectories, designing efficient machinery, and analyzing the dynamics of complex systems. 4. Dynamics overview. Dynamics, on the other hand, is concerned with the forces and torques that cause objects to move and change their motion characteristics. It explores the principles of force, mass, acceleration, and the interactions between objects, focusing on understanding why objects move the way they do under the influence of external forces. 5. Components. In dynamics, the key components studied include force, a push or pull exerted on an object, mass, amount of matter in an object, acceleration, resulting from applied forces, and momentum, product of mass and velocity. These components are governed by Newton's laws of motion, which form the foundation for analyzing the cause-effect relationships in moving objects. 6. Applications. Dynamics is essential in engineering, physics research, mechanical design, and aerospace industries, where designing systems, predicting collisions, optimizing vehicle performance, and understanding fluid dynamics require detailed knowledge of forces, motion, and energy transfer. 7. Relationship. Kinematics provides the foundational description of motion, outlining the parameters that define an object's movement, position, velocity, acceleration, while dynamics delves into the underlying forces and interactions that influence and change these parameters. Together, they form a comprehensive framework for studying and predicting the behavior of physical systems. 8. Integration. While kinematics focuses on describing motion quantitatively through mathematical models and graphical representations, dynamics extends this understanding by incorporating the principles of force, inertia, and energy to explain how and why objects move as observed in real-world scenarios. Conclusion. Kinematics and dynamics are fundamental branches of physics that study different aspects of motion and interactions in the physical world. Kinematics describes the motion of objects using parameters like position, velocity, and acceleration, without considering the forces causing them to move. In contrast, dynamics focuses on the forces, torques, and interactions that govern motion, applying principles like Newton's laws to explain the causes of motion changes and interactions between objects. Understanding the differences between kinematics and dynamics provides a foundational understanding of motion, essential for various scientific, engineering, and practical applications.